All right, welcome everyone, and let's continue on. This is going to be part 5, I believe, and yeah, so let's just do what we always do: difficulty easy, algorithms, and then sort by acceptance rate, and then let's just open up 10 problems, right? So XOR operations in array, I guess it's different. Okay, 1, 2, 3, 4, 5, 6, and go to second page. 7, 8, 9, 10. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so we got everything, I believe. I think this one is a bit buggy, so I'll just try that. We will what? Okay, this problem is just not loading up for some reason. This is so weird. Let's just see what's going on if I can. Okay, fail to load resource. Yeah, that's weird. There's something wrong with the backend service for this problem. Okay, let's just go to the next problem then, I guess. Truncate sentence, number of steps to reduce a number to something. Okay, let's just try again, like truncate sentence. Okay, maybe it was just a backend error on the time. Okay, never mind. Cool, all right, and let's start the stopwatch. It's not a stopwatch, it's a timer, I guess. Yeah, but well, whatever. All right, let's start, shall we? Okay. All right, so XOR. You give an integer n and integer start, okay, and then define nums where nums I start plus 2i, and is the nums of length thing. Okay, return the bitwise XOR of all the elements of nums. Okay, I guess what you do is you're just multiplying it by the index and then adding the start. Okay. Multiplying it by the index, adding start. Okay. I guess there might be some clever bit manipulation way, but I think I'm just gonna do with what you know what a normal person would do, I guess. So, that's the thing. Should I create a new list and then do XOR on everything, because that would create O(n) complexity of space. But I think I can just do two numbers at a time, right? So let's just do like first number would be start, right? So it's always going to be start, or is it not? Wait, let me see. So it's start plus 2i. But in this case, oh yeah, it is. Okay, I was thinking something else. But in here, we have start. Oh, it's a 0. Okay, that's fine. Okay, I made a mistake. Okay, so first is that, and second number is going to be 2 plus start, right? Because I is integer, like 1. So n can be 1. Okay, I guess there is an edge case. So let's just do like if n is equal to 1, return start, right? Okay. And if it's not, then we just have it like first and second number. And then what I'm planning to do is just basically do loop to get the third number and stuff like that. So for I in range, I think we can do 2 and n, I guess, until n. Okay. And then what I can do is, so we have the, let's just call it XOR, right? So XOR is the first, XOR second. So that's our answer. That returns XOR. But the next one, the third number would be, I guess we can also overwrite the first number, I think, and then we could just, yeah, right? So we go there, and then first number is the second number. First number is going to be the second number. Then second number is going to be 2 times I plus start. Then XOR is going to be it's going to be the second. I think that's what it is. Okay, let's just try this. So with this, it's going to be just O of n, not O of 1 complexity, O of n time complexity, okay? So I think this is just a much better solution than creating like a list and then XORing everything, right? So yeah, I think that's a much better solution. Okay, yeah, we beat 89%, that's good. So time complexity would be of n, but more importantly, space complexity is O of 1, because we just have like 3 variables, right? But the other solution, the brute force solution, would be O of n space. So that's the important part. All right, so let's move on to the next one. Create target array. Okay, this might be a little bit long to understand, but we'll see. Given two arrays of integers, nums and index. Okay, so both are arrays. Okay, your task is to create a target array under the following rules. Okay, initially target array is empty. Okay, it's empty. And from left to right, nums I and index I insert at index the value of the target array. Okay, repeat the previous step until there are no elements to read in nums and index. What? Okay, return the target array. It's guaranteed that the insertion of operations will be valid. Okay. Let's just check, right? Okay, so we have nums and then indices. Output would be that. Okay, y. So we have nums of 0, index of 0. Okay, 0, 0. The target would be the 0th number, 0th index. Okay, 0. That makes sense, I guess. Nums I is 1, but index is... Okay, this is so confusing. Oh my god. Why did they do it like 0, 1, 2, 3, 4? Why can't they just put like easy numbers? Insert at index I the value nums I in the target array. Okay. Repeat this previous steps until there are no elements to read in nums. Right. I guess let's just follow this rule and then see what happens. For I in range, length of nums, so they're just both equal, right? And then target. But is the target going to be the same length? I assume so, right? Yeah, okay. Let's just do like target dot append insert that index I the value nums I. Okay, index I to 1. Oh, okay. So you're it's inserting in the middle. Okay, so for example, like here, it's inserting this number at this index. Okay, so it's not appending actually. Huh. Well, I mean, there is in the insert function in Python that does exactly that. Let's just do like insert target dot insert. Which number am I inserting? It's the nums I at index of I. Turn target. I'm not sure if this is gonna work. Let me just see. Okay, maybe it's the other way around. Okay. Okay, yeah, it does work, but I'm not sure if this is the optimal solution though, because like insert function itself is O of n, and then we have n, so which means it's n squared. So I mean, let's just try and see what happens. Okay, it's a little bit on the slower side, but it's still fast. I wonder what's the optimal solution in here though. Like, because like, I don't think there is one actually. There's just no way of doing this, I think. Or maybe there is. Let me see. Yeah, I don't know. I don't think there is an optimal solution. Let's just see the hint. Simulate the process and fill the corresponding design spots. Okay, yeah, I mean, we are doing that. Okay, let's just, maybe it's just this is the problem. Okay, we just have to use the insert function. So time complexity is definitely going to be O of n squared because the insert function is itself is O of n, and then we're just doing loops, right? So that's why it's O of n squared. And then space complexity is obviously O of n because the target itself is O of length n. So that's why. Okay, let's just move on to the next problem. All right, third problem. You're given 0 index integer array nums and an integer k. In one operation, you can remove one occurrences of the smallest element of nums. Return the minimum number of operations needed so that all the elements of array are greater than or equal to k. Okay. After one operation becomes that. Well, okay. Isn't it? Aren't we just going to count all the numbers that is less than 9, for example? That's it, right? It's so easy. Okay. So let's just do that. So count to 0 for n in nums. If n is less than k, count is 1, return count, right? Okay, yeah. So basically, like, you don't really care about like you're removing the smallest element, right? It doesn't really matter. What matters is like how many numbers are less than k, and then you just return that because like every time when we were doing operations, we're just removing one number, right? So yeah. So it's just that. Okay, cool. And there is no optimal solution than this. This should be the most optimal. So time complexity is O of n because we have a loop, right? And space complexity is just O of 1. Okay. Okay, let's next problem. Minimum number game. Okay. You are given 0 indexed array, a lot of array problems. Okay. You're given 0 index integer array nums of even length. Okay, and there is also an empty array R. Okay. Alice and Bob decided to play a game where every round Alice and Bob will do one move. The rules of the game as follows. Every round, first Alice will remove the minimum element from nums, and then Bob does the same. Okay. Now, first Bob will append the removed element into the array R, and then the Alice does the same. Okay. The game continues until nums become empty. Return the resultant array from R. Okay. Cool. Okay, let's see. So I think the idea here is that I think I know how to do this. So we just basically sort and swap every other two, every like two numbers, right? So for example, like if so in this example, right? So we have 5, 4, 2, 3, right? So 5, 4, 2, 3. Let's sort these numbers, right? So it's gonna be 2, 3, 4, 5, right? And then we just swap every two, like these two and then these two. So it's gonna be 3, 2, 5, 4, and that's it. That's the problem because let's say that, for example, right? So the first rule, right? First rule is just we're removing the minimum and also the next minimum, right? So we're removing the minimum elements. And then let's imagine that we put those minimums into the nums array, right? As soon as we remove it, right? So that basically means we are sorting it from minimum to maximum. But the orders are different, right? So because the second minimum comes first and then the minimum comes next, right? So that's why we need to like swap every other number, like not every other number, swap like the even index into the odd index, even index to the odd index, like neighboring numbers, I guess. I think that's a better way to call it. Okay, so let's just do that. Nums dot sort, right? And then for I in range, I think we can just do it until like length of nums divided by 2. I think that should work. And then nums of 2 times I. So in Python, there is like a neat swap function. So typically in other languages, what you do is you have to create like a temporary variable to swap it, right? But in Python, you can just do this. This is a pretty neat trick. Not neat, not a trick, I guess, but it's something that you can learn. Okay, so basically what I'm doing is I'm assigning this number to this and this number to that. So exactly what swapping is, right? But in other languages, you have to create like a temporary variable and then you do the swap operation. Okay, let's just do that. Okay, cool. All right. Beat 19%. Wow, okay. Is there a ON solution to this? I don't think so. Because you're getting the minimum every time. Okay, yeah. That's what I assumed. Yeah, I don't think there is a ON solution to this, honestly. Or maybe there is? I don't think so. No, I don't think so. Because we're getting the minimum every time. So there has to be a log n solution for sure. Okay. So our time complexity is of n log n because we're sorting it, right? But the space complexity is actually just, we can assume it's O of 1 if we were doing quick sort, but I think in Python the this sorting can be like treated as O(n) or something like that, but we can just assume like theoretical sorting is like O of 1 because we can use quick sort, right? So we can just do that. All right, cool. On to the next problem. All right, what's this? Find a corresponding node of a binary tree and a clone of that tree. Okay, given to binary tree, original and cloned. Okay, we have original and cloned and target. Okay. And cloned and given a reference to a node target in the original tree. The cloned tree is a copy of the original tree. Return a reference to the same node in the cloned tree. Note that you're not allowed to change any of the two. Okay, I think this is a pretty straightforward problem. So we can just do like recursion, not recursion, sorry, depth first search, right? Like any kind of like trace traversal methods. It can be anything. And then we just, say whenever we're traversing, if the target is the current node, then we just return that cloned node's like current node, I guess. So yeah, I'll just show you what I mean. So I think, I don't really want to do recursional tree approach because that's kind of easy, right? But maybe I should because that's easier to read. But if I am doing that, then yeah, let's just do that. So DFS, DFS. So that's like a depth first search, right? So we have node 1, node 2. So that's the traversal current node, I guess. So if node, so that's the base case, right? If node 1 is equal to target, then return node 2. So that's the precondition, right? So if that's not the case, then we just do, I guess what we can do is like if node 1 is not none DFS left, okay? And then node 1 dot left, node 2 dot left. If node 2 dot right is not none, DFS of node 1 dot right, and then node 2 dot right. Okay. And then we just return, let me see. I have to capture the element though. Okay, let me see if, let's just do like L, not L, I guess. Oh no, let's just do like R, which is the result, right? None. And then R equals r equals return r. I think this should work. Let me just see if it doesn't work. Original cloned. I mean, yeah, it does work. But yeah, I don't think this. Well, I think these are just worked on the on this case, but I think it's when I submit it, it's not gonna work. I'm pretty sure, because like, what if I find the answer and then it goes here and then it just overwrites it as none, right? So and then let me just do this. R is none, and maybe, yeah, I think this should work. Okay, let me just do that. Okay, now it works for sure. The reason why I added this is because let's say I find a node in here, right? So that's R. And then when I do the traversal, it might just override it as saying R equals none, right? So let me just submit this and see if I'm right. Yeah, exactly. So you have to add this condition to make sure it's right. Okay, cool. So I think my previous submission was really, really fast. So that's fine. Okay, so it's pretty straightforward. Like on tree, the depth first search traversal is like you just go to the left, left, left all the time, right? And then whenever it's exhausted, you just go to the right, and that's it. That's like the only two paths, right? So that's pretty easy, straightforward. And you can also do this with like queues and stacks and stuff like that too. Yeah. So in terms of time complexity, it's O of n, and n is the number of nodes in the tree, right? And in terms of space complexity, the maximum can be O of n too, because the tree can be like, it's not a balanced tree, right? I mean, it can be just slanted like on the right tree, but on average, like if it is a balanced tree, it's going to be like O of n, because like every time there's a recursion, there's like a recursion stack. So we have to keep track of that, and that's basically the height, right? The height of the tree is this. So yeah, the worst case scenario is going to be like O of n. So the tree is like not unbalanced, I guess. It's like skewed towards one side. Right, so let's move on to the next one. Decompress RLE list. So how are we doing on time? So we have 1, 2, 3, 4, 5 problems solved. So we have in 22 minutes, so that's pretty good. So we are given a list of nums of integers representing a list compressed with run length encoding. Okay. Consider each adjacent pair of elements frequency and value. Okay, yeah, that makes sense. For each such pair, there are frequency elements and a value concentration. Sublists concatenate all these sublists into left to right and generate the decompressed number, decompressed list. Return the decompressed list. Okay. So it just means that we have number 2, 1 time, like that's the frequency, right? And then number 3, oh no, sorry, number 4 has 3 times. So that's it. That's pretty much it. Okay, let's just do that. For I in range, length of nums divided by 2, right? It's because there's like frequency in pair. And then the answer is just, let's just call it as empty list for now. And then what we can do is like in Python, you can just add list on top of a list so that it will just get extended, right? So that's like one of the Python's trick advantages, I guess, not a trick. So what you can do is like, okay, frequency is nums 2 times I, right? So that's the frequency. And then we can just do square brackets, nums 2 times I plus 1, and then multiply it. So let me explain this, right? So whenever I have something like 0 times 4, this, right? So this will result in like 0, 0, 0, 0. So I'm just exactly doing that. That's it. So I'm just copying this number with the square bracket, means it's a list, right? And then I'm multiplying it by the frequency, which is the, the 2 times I element. That's it. And then whenever in Python, you can add 2 lists, right? So for example, like 1, 2 plus 3 would equal 1, 2, 3, like that. It's easy as that. All right, cool. Let's just submit this. Great. All right, so in this problem, I think the space complexity and time complexity is really, really difficult to tell. Time complexity, space complexity, because it will depend on the frequency, right? Like, I mean, what's the frequency limit? I guess it's 100. Okay, so the frequency is 100, right? And then every element can be like 100, 100, 100, 100, right? So that means the size can be like 100 times. I mean, it's really difficult to tell. So technically, maximum number can be like 2 to the 34, right? So each frequency can be like 2 to the 34 times n, basically. So that's like the space complexity and time complexity. It's really weird. So I can just write down as like 32 times n and 32 times n. So which is a huge number, right? So, but I mean, yeah. And also, like, if you're appending lists, I mean, yeah, it's pretty tricky to calculate the time complexity in here. How should I explain this? This process will take the frequency, and when we're adding list on top of a list, that can take like O(n) time too, because it's like adding like a huge chunk of lists together, right? But sometimes it's not. On average, it's just not gonna be like that. Okay, so we can just leave it at that, and then we can just move on. Okay. Count of matches in a tournament. Okay, what is it saying? You are given an integer n, the number of teams in a tournament that has a strange rule. That has strange rule. Wait, what? Number of teams in a tournament that has strange rules. Okay. If the current number of team is even, each team gets paired with another team. Total of n divided by 2 matches are played. Okay, that makes sense. We just basically half the team gets move on to the next stage. If the current number of team is odd, then one team randomly advances to the tournament, okay, and the rest of it gets paired. A total number of n minus 1 divided by 2 matches are played, and teams advance to the next round. Okay, that makes sense. Return the number of matches played in the tournament until winners decide. Okay, pretty straightforward. Okay, so with a problem like this, right, you don't know when to end, right? So that means this is a perfect case of like having while loop, because we don't know when it's going to end, right? So if n is even, then n is equal to n divided by 2, which is, you can just do like this. And if it's not, then n is equal to n minus 1 divided by 2 plus 1. So it's written right there, right? Oh yeah, we have to do a count. Count is 0. Count plus 1, count. Okay. Maybe it's wait, what's the return the number of matches? Oh, it's the matches. It's not okay. So matches is like, so in here we have number of matches is like n divided by 2. So I guess I'll just create like a matches function. Or not. Wait. Yeah, let's just create like a matches function, and then n is gonna be equal to the matches in this case. Okay. Not function, sorry, variable. And then in here, matches is gonna be n divided by n minus 1. 1 divided by 2. That's the match count, right? But the number of teams remaining was gonna be matches plus 1. So just written right there, right? So, and then count is gonna be number of matches. Oh yeah, count is the same. Okay, here. All right, cool. That's the simulation, but I'm wondering if there is a good mathematical approach to this. There might be like a solution where you just create a bunch of equations and then that's it. But I mean, still, this is like kind of like log of n, right? But the mathematical solution, if it's involve like a logarithm or something, it's still going to be like log. So I believe this is good enough solution. Okay. Cool. All right. So the time complexity is actually log of n, right? Because every time the matches is halved, so that means it's like logarithmic timing. The space complexity is also just O of 1. Okay. And that's it. Right, now let's move on to the next problem. But I'm wondering, like, why is it like saying 7% though? Oh yeah, I always want to try this feature. Let me just try see if this works. Yeah, okay. Yeah, it's helpful, I guess. But I think this is a limited feature where daily there's a limit. So, but yeah, that's it. I think it's only showing the time complexity, right? Yeah, it doesn't show the space complexity. So, whatever. Maybe it's helpful to some people. Now I'm wondering if there is a good solution. I don't think there is. Simulated tournament. Yeah, I'm doing that. Be careful handling the odd integers. Okay, yeah. I mean, I am doing that. So let's just move on. Given a positive integer n, find the sum of all the integers in range of 1 and inclusive that are divisible. Wait, what? Divisible by 3, 5, 7. Okay, return the integer denoting sum of all the numbers given satisfying the constraint. Divisible by 3, 5, or 7. Okay. So basically, count every number until n, until there is 3, 5, 7. Okay. Of course, we can just do it as a brute force and then do it with log of n. But I'm just thinking there is like a really good solution, like mathematical solution. But there is also like a really bad way of handling this because, well, you can technically like calculate every number that is like this, right? 12, 15. Okay, so this is like basically every number that is divisible by 3, you can calculate the sum easily because this is like a arithmetic progression, right? Even if you don't know arithmetic progression, then you can just put 3 in front, and then it's just going to be like 1 plus 2 plus 3 plus dot, right? And then we all know the summation of this part, which is n times n plus 1 divided by 2, right? So, and then this is just 3 times that. And then because of this, you can just calculate the same thing for 5 and 7, right? So 5, 15, and then 7 plus 14 plus 21 plus 28, blah, 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 right? And then the equation would be 5 times that, and then this would be 7 times that. Okay, so those are going to be the sums. But obviously, as you can see, there's a problem, right? The problem is that whenever there is a divisible by both numbers, right? So for example, 15 is divisible by both. Then you have to subtract one of them. So because we're double counting it, right? So essentially, you have to subtract like 15, 30, 45, and so on, so on. And there's also a case of like 3 and 7, right? So 3 and 7 would be 21, 42, 63, right? And then so on, so on. And then there's something case where 5 and 7, which is 35, 70, 105, you have to subtract those. And also you have to subtract like divisible by every number, right? So 3, 5, 7, so that's like 15 times 7, which is 105. So 105 is also being double counted as well. Maybe it's triple counted. Let me see. If I'm subtracting that, maybe it's just, maybe we have to add it though. It might be the case. So yeah, so we have to take care of those edge cases too. So it's a fun problem to optimize it, but yeah, you can do it mathematically for sure. But you know, if you're too lazy, then you can just do it as like this. So for I in range of like 3 and n plus 1, it's because it's inclusive, right? And then you can just do addition by 2 because you don't care about the oh wait, we do. Yeah, sorry, I was thinking other stuff. Okay, so we just basically go from 3 until n plus 1, and then if I divisible by 3 or I is divisible by 5 or I is divisible by 7, then I'll just calculate the sum, right? S is equal to I, return S. And I think this just works fine. Okay, let's just submit it and see if there is, the speed is basically, I mean, the speed is really good, I guess. Beats 41%. But there are some solutions which are really, really fast, but I think those are the mathematical solutions that I was talking about. I think since we have time, let's just try to do that. Let's just try this mathematical solution. Okay, so for example, like 3 sum. Okay, so n, let's just call like n sum, right? N sum would be n times n plus 1 divided by 2, right? And then 3 would be the 3 times, 5 would be the 5 times, 7 would be the 7 times, okay? And then, oh wait, I cannot do this actually because, okay, gotcha. So I have to create like a function def and sum. And then I guess let's just call it k because the n is a different return k. Okay. So that's the k sum. Now what we can do, let's just do this solution because it's really easy. It's just obscuring the vision, right? So so we have the function. This is just, calculate the sum 1 until whatever number, right? The number we desire. Okay. Now what we can do is like sum 3 is equal to k sum n divided by 3, right? So that's like the sum 3. And then sum 5, it's k sum n divisible by 5. Sum 7 is k sum n divisible by 7. Okay, so those are the sums. And then we have to also calculate sum 15, which is k sum n divisible by 15. Sum of 21, k sum n divisible by 21. Sum of 35 is k sum n is 35. Okay, and then finally we have to do sum of 105, which is divisible by everything, right? So sum of n divisible by 105. And then we just basically add all those things together. Let's just call it S so that we can save time writing stuff. Okay, S3 plus S5 plus S7 minus S of 15 minus S of 21 minus S of 35. Okay, so let's just do this, right? And then I think there should be plus S of 105 because I think whenever we're subtracting these, we're also subtracting the 105s. So that's why we have to plus add it. So I think that's the case. Let me just do that. Oh, wait, what? Oh, yeah, of course, there's a syntax error. Okay, it didn't work. Expected 25, output 5. Oh, it's 3 times though. I forgot that. 5 times. 7 times. 15 times. 21 times. 35 times. 105 times. Okay, let's just do this. Okay, hopefully this works. Let me see. Okay, yeah. Ours is like super good solution, right? So We're awesome. We did it. 99 percentile. That's pretty awesome. So let's just analyze the complexity. It should say, oh, it's a done deal, right? Okay, whatever. Okay, so time complexity should be O of 1, and space complexity is also O of 1. The other solution is actually O of n, right? So, but this here, it's like O of 1. We're just, using divisions and multiplications and stuff like that. So, pretty cool solution. We just have to, understand like why we're minusing it and why we're adding it. So, just I would say like typically the signs changes like plus, minus, plus, like it just goes like that. But in reality, the reason why is because we're subtracting like three things, right? So in here we're also subtracting the 105s. In here we're also subtracting 105s. In here we're also subtracting 105s, right? But also we triple counted like 105s in here, so that's why there's like one missing 105. I think that's how we should see it as. So yeah, something like that. If you write it down, it will make sense. Okay, let's move on to the next one. Check if two string arrays are equivalent. Okay, if given word string arrays word 1 and word 2, return true if two arrays represent the same thing, and false. Okay. What do you mean represent the same thing? Oh, when after joining it, a string is represented by an array of the concatenated in order to form the strings. Okay, yeah. Okay, gotcha. So in Python, this is pretty straightforward. So we can just do do one line solution. You could just join word 1 equals join words 2. And that's it. Just basically joining and comparing it, right? So yeah, this is exactly what it does in Python. So this is also one of the reasons why I recommend using Python on interviews. So you can just have like these nice functions like instantly. So in here, space complexity is going to be, I believe, like number of characters. So you can just say O of n, I guess. N is the number of characters. And time complexity would be like number of characters. It can be maximum number of characters, right? Because it can be like one character repeated n times. So that's why the time complexity can be maximum over n too. So, okay. Let's move on to the next one. Truncate sentence. Okay. What is it saying? A sentence is a list of words that are separated by a single space with no leading or trailing spaces. Okay. Yeah. Each of the words consists of only uppercase and lowercase English letters, no punctuations. Okay. Cool. You are given a sentence as an integer k, you want to truncate s and such that it only contains the first k words. Okay. All right. So there is actually like a one line solution in here on Python too, but I don't think, I mean, definitely it's not the optimal solution for sure. So one line solution would be just like the previous problem. There's a split function, right? So I can just do like a split like that. So this will give me like string of array of strings separated. I mean, each element would be this and separated by space, right? So this would give me that, and then I can just get the first k items of the list. So I can just do that, and then what I can do is also just join it again. So after this is gonna give me a list, right? So I just join with the space again, and then do this. Pretty straightforward. And then this would give me the good solution too, but it's not going to be the optimal solution, of course. Oh yeah, but it's still pretty good. It's 43%. Okay. But this is not the optimal solution. The optimal solution would be to count the number of spaces, right? So for example, right, let's just go and analyze character by character. And then if c is equal to space, then there's like a count. I increase the count. And then if count is, okay, so if we have k is 4, that's 4 words, which means this is 4, right? And then which means we have to have like 3 spaces in between. So if count is equal k minus 1, return, oh, I guess I have to have the index as well. Okay, let me think. actually, there's like an edge case now that I get it. Okay, now I get it. So in here, if I'm 1, 2, 3, so if I stop as soon as I hit 3 spaces, then I'm not getting this word, right? So that's why I have to get until 4 spaces to get the index until this word. Or if there is like a end, right? So yeah, I have to go until count is k. And then what I can do is return s of everything until I. All right. If this condition isn't met, then we just return everything, because most likely it's just the end of the sentence, and then we have to return everything, right? So I think this should work. Oh yeah, it's enumerate. So we have to do enumerate to get index and value at the same time. Okay. Okay, cool. I mean, it's the same speed, but yeah, but theoretically this is more optimal because time complexity wise, I guess this can technically go until at the end, and space complexity wise, it's tricky because it can also go until the end, return almost the end of the sentence, right? So it's also like O of n too. But it is, in terms of calculation wise, it is not going until the word, right? Until the s. So it's much faster on average, the solution. Okay. All right, so we have 15 minutes left. Let's just review our profile and see if there's anything I've missed. It should be 50 problems now. Okay, yeah, 50 solved. That's good. Great. So now we officially ended like in 45 minutes. So that's good. All right. So this has been the part 5 of our easy LeetCode under 1 hour video series, and most of the problem has been dealing with like array problems, right? And then we had one tree problem, and then also an array problem, string problem, like some problem with like good math in here. That's something that I really liked. And then in here, I guess it's just a string problem. So it's a string, array, math, and tree problem, I guess. Okay, that's been a good series, and talk to you guys later. Bye bye.